I also work here at LaunchGap with the crowd here. Um, over the past year, I've been getting into machine learning, been learning a lot about it. I'm a React developer by trade, and I've been doing a lot of Rails stuff recently as well. But yeah, I think there's a lot of cool stuff happening in the web platform for machine learning, especially in the JavaScript space. And a lot of new tools have opened up. We've inherited a lot of stuff from Python recently, and as well as some new browser APIs that are making machine learning in browser a possibility. So yeah, let's get into it. Okay, so I'm pretty sure everyone has heard about machine learning. It's been kind of the year of machine learning this year with ChatGPT and all that. But we'll go over, kind of some use cases for it. For example, like Zoom uses it for their background filter. So if you were to blur your background right now, that's actually an in-browser. If you're using Zoom Web, it's an in-browser model that's running in the background on a service worker, or I guess on a background worker here. But that's processing your video and altering it at all in real time. Predictive analytics, a lot of industry uses supervised learning models to do all sorts of predictive stuff, classification, image classification, token classification for NLP, which we'll talk about more. But yeah, all sorts of stuff. It's really taken off recently with a lot of the large language models and generative AI, but that's actually a small fraction of what exists out there in the field of machine learning. Okay, so let's go to formal definition before we get started, because I guess it's important to be formal about some things. But the formal definition is that a program is said to learn from experience E with respect to some task T and performance measure P. If the performance at task T is measured by P improves with experience E, your model is learning and your machine is learning. So we'll talk about the different kind of models that exist. There really are two. There's supervised learning models and there's unsupervised learning models. And the big separation between the two is architecture largely, but also the way that the data they're trained on is labeled. For supervised learning models, that you generally split your data into a training set, a validation set. You train the model in your training set, and then you validate that your model is not only trained on that data with your validation set. Unsupervised learning is generally neural networks, and you just give it a bunch of raw data, and you hope that it finds different similarities between the data, and it clusters the data based on their similarities and what the model has found. And you'll see that here in the bottom right. That's clustering is something you'll see with unsupervised learning. That's a latent space. You might hear like multidimensional, a way to map multidimensional space, but we'll talk about it later. And then classification, which you can do in unsupervised learning models with a few extra steps, but like something like a random forest classifier, which is just a bunch of decision trees that vote on an input. That could be a supervised classification model. But yeah, let's talk a little bit more about supervised learning. I kind of went over the issues with it or the structure of it, but the biggest issue is overfitting. If your data is going to vary from input to input widely, and you're not sure what the input in the future might be, it's really not a practical application for it. But for a lot of industry, they know what the input's going to be. The variability is not too large, and their training set can generally be pretty close to what they're going to be using it on. So it's good for industry. But overfitting is an issue. So as soon as you want to give it an input outside of that training data, it really does not perform very well. And that's why unsupervised learning was created. This is probably what you've seen. I don't know if people have seen videos about it or like the neural network, but that's essentially what this is. For example, if you were going to take a picture and you wanted to run it through a neural network, you would take each pixel from that picture and you would map it to a flat array, and you would pass that array into the first layer of the neural network, and you would assign it'd be an array of numbers, and based on the brightness or color of the pixel, you'd assign it a number. And then each layer, some math is done to those different layers, and the layers expand and contract. And then at the very end, you get your network decides essentially. You might get a 0 or a one being dog, a 0 being cat, and that this network is classifying those images based on the inputs you get. This is going to be super informal as well. So if at any time you guys want to stop me and ask questions or interrupt, I'm more than happy to do that. Okay, so if you take the last layer of a neural network, this one right here, the output layer, and you take all those number values and you map it to a multidimensional latent space. You get something called a cluster. You take a bunch of inputs and you map them in this latent space, and you can kind of start to see how the deep neural network is visualizing this data. Go ahead, Tim. Yeah, go ahead, Ryan. Let me see.
Hey, sorry. That dog example though there you had on the previous slide, that's a classifier, not a is that unsupervised learning?
Oh, let me go back. So deep learning neural nets can do classification too. They can pretty much do any task you give them, assuming it's a discrete input and discrete output. Yeah.
You would need some sort of concept of what is a dog. Like otherwise you're just getting a random binary classification of one category to another another category though.
Yeah, I mean, I'm not exactly sure how the deep models are trained, but essentially you get a ton of data, and then you like look at the latent space, and then they're trained by something called gradient descent, which is like if the model is not very good, you kind of do supervised learning rounds on the model where you say like, okay, this is kind of this is the direction we want to go, and then you do more and more training runs until your model improves to the point where it can classify a dog or a cat. I'm not, for web developers, I think it's not really important to understand how they work really, just that they do work. And we're going to talk more later about kind of the pre-trained options that are available to us as web developers, whether we can go through APIs or we can go through open source via Hugging Face. But what we need to do as web developers in terms of interacting with deep learning models is fine tuning at most. And there are tools now that you just give it your labeled data, and essentially you like LoRa is a tool you can use to fine tune deep learning models. And that's all you need to do. There's no necessity to train these because there are different architectures like the transformers, the new architecture for doing NLP models, and it's also really good at doing image models as well, like the generative AI stuff. But yeah, anyway, does that answer your question? Sorry, I kind of rambled there.
I think it's good to go ahead. Go ahead.
Gotcha. All right. So if you take a look at the latent space here, this is the abstraction for this trained model. It's what it sees when you pass it a picture of hand-drawn numbers. You can see that all the numbers that kind of look like one are clustered together, and then all the numbers kind of look like 8 are clustered together, but there's all sorts of discrepancies around there. And if you ever wanted to know how similar one is to another, you'd have like your sample hand-drawn one, and you would find out the distance in this space between that hand-drawn sample and the one that you just passed in as input. And you can do that with all sorts of things. You can cluster data with any sort of input. So Spotify, for example, has an embedding for you based on your songs and what you've played. There's all sorts of different embeddings all over the place. And we could talk about models that are designed strictly for generating embeddings. They don't actually do a task. They just generate embeddings that you can use to do whatever you want. So let's talk about NLP and transformers for a bit. So it's not super important as web developers that we know what it does, but it's kind of taken the world of machine learning by storm, and it's responsible for the generative AI like ChatGPT and Stable Diffusion. And NLP is natural language processing. It's the text generation part of machine learning. And if you are going to do any sort of more in-depth thing with a transformer, you need to use a tokenizer. So essentially you bring in some text and you want to say like, hello world, like a type.
Can you do a font bump on that?
Yeah. You see that? And then it'll map your strings, each individual word or sometimes parts of words to numbers. And essentially what they've done is they've taken the English language or sometimes multiple languages, and they've figured out how to represent each word or part of a word. They call it token as a number. So we can look at the actual text and how it's split up, and we can look at their example. And sometimes words are split up into individual tokens that are not indivisible. There's no one large token for indivisible, so it's a combination of 3 tokens in this case. And that array, this one here, is passed into the first layer of your neural net. So go back here, that would be passed in here, and then some math would happen on each layer, and there's all sorts of different architectures. The transformer architecture has something called a self-attention head. I don't really understand how it works, to be honest, but it's what it is. And then it will do some calculations. In this case, this is just the next token predictor. So it'll return a number, and that number is mapped back to whatever the English token representation of that number is. In this case, exclamation mark. And then you get the next token predictor. Okay, so a little bit more about large language models. This is kind of the outcome of the transformer. Like, for example, with ChatGPT, this is kind of the meme that came around when it came out. They essentially fed it the entire internet during the unsupervised round. They did some supervised fine-tuning to fine-tune it for conversation. And then they did a RLHF, reinforcement learning with human feedback rounds to make sure, I guess, it doesn't like tell you how to make napalm and stuff. But that's like a much more complicated architecture in terms of a model, but nicely all of that's abstracted away for us in these tools, and we can just call them as APIs essentially. Okay, so what has happened in the web space that now that we've kind of gone over, what's out there and a brief overview of sort of how they work. Why do we care as web developers? Well, I think everyone agrees now that it's kind of the hot topic. I think a couple of people said it's people want to, integrate it into their products. They want to know how they can integrate it into their products. Everyone kind of wants to use it, but nobody really knows how they want to use it. But the web platform is actually a good time for this blow up, because the web platform has been working on and just integrated a few to the standard web machine learning APIs. The first one being WebGPU, which is gives the browser direct access to the GPU. The previous API was WebGL, and a lot of libraries like TensorFlow JS used it to kind of come up with hacky solutions for their machine learning libraries to run calculations on the GPU. But there's a lot of memory mismanagement there, a lot of duplicate logic had to happen. It just wasn't, it was made to draw triangles on the canvas, not to actually run neural networks. So the WebGPU gives first-class support to run neural networks on the web, which is going to be huge. I think in their marketing material, they said 100x claims of speed. I've never seen a marketing brochure that doesn't have 100x on it, but I think it's pretty interesting. In the demo I'm going to show later on the extension I wrote, unfortunately, it's available everywhere in the web except for service workers, which is the one place that your extension needs to run background scripts. So anyway, I had to use WebAssembly, but we'll talk about that later. Another one that's been proposed to enter the standard web, and it's pretty late in its adoption, or it's in its late stage, good to be adopted. It's looking pretty good. Is the Web Neural Network API. There's like a lot of different devices and a lot of different architectures that like neural network library creators need to keep in mind when they're developing their models and things like that, or displaying them or deploying them onto certain devices. The Web Neural Network API is going to abstract that all the way and essentially just give people direct access to the client's GPU, no matter what device they're running on. So even if they're running on Android or whether they're running on Mac, it's going to be the same API for whatever developer is working on. And it integrates with WebGL, WebAssembly as well, which is really nice. It's not available yet, but it's in the pipeline, and it's really exciting for WebML. Another one is WebAssembly. This one's been around for a bit, but it's really good at running smaller models. It runs on the CPU, and a lot of these models are implemented in C++ or Rust that run on the back end. But WebAssembly is multi-threaded, So you can actually, at least take advantage of the client's threads or the client's cores to run models more quickly. Again, unfortunately, for my extension, I had to do it single threaded because of an issue with one of the libraries, but it is in the books to be able to run multi-threaded models or run models via multiple threads. Just a couple some important terms to go over. I'd say a model is just a mathematical model performing inference on the input. When people say that, they're talking about like, we're running this model, this model, this model. It could be a supervised learning, it could be a deep learning model, but it's essentially the thing that you're giving an input to and it's responding with an output and it's doing some sort of inference on it. An embedding, that's a big array of numbers that you can map to a latent space. You can compare with other embeddings via things like dot product and cosine similarity and kind of figure out how similar they are. You can also use them in vector stores that are really popular right now, which is another thing that it's not part of this talk, but it's more of like a large language model, giving them context to your documents and things like that. Latent space, that's the graphical representation of that kind of embedding area. It's like a multi-dimensional graph, and there's different tools you can use to visualize it. NLP, natural language processing, and then zero-shot learning. Or zero shot just in general. That's kind of what I'll be demonstrating today via the Hugging Face model we're working on. But zero shot's great because it's what deep learning networks really excel at, these ambiguous inputs, and you can get gainful utility out of a model that has never seen your data, but is similar enough to it that you can still use it. So if you're looking to integrate a model into your web app, I think the first place to start would probably be Hugging Face. There's a transformers.js library, which maps to the Python Hugging Face package one-to-one, and it supports more and more models every day. But let's say you wanted to, for your specific task, you wanted to go here. So yeah, sure. So let's say we wanted to go and we wanted to do image classification, or in this case, we wanted to do NLP. So we go natural language processing. We want to do zero-shot classification. And you'll get a bunch of different models and a bunch of different architectures. And generally, trending is a good way to sort because the hottest model is generally the best one at the most tasks. You can see how many downloads. This one's really good. It'll usually give you a paper as well. So if you want to, actually read the architectural decisions they made and training decisions they made and the data set, sometimes you can get that there. Tim, when I was demoing this talk the other day, pointed out that it's important to have the MIT license or another open source license if you are going to integrate these products into your web app. But once you can also play, they all have an API here that you can play with. So this is, we can just say, I don't know, talking dog, and we can give it two different possible categories. Let's do dog or cat. I guess it's not. And it should be very highly on the dog side. There we go. It's pretty sure that this string is closer in relation to dog than cat. And you can try all sorts of different things, and you evaluate it on whatever you want to do. But that number right here is essentially the output of the neural net. Okay. So the other library that made it interesting to JavaScript users is that this transformers.js has historically been only for Python. And just recently, I think in the last few months, they've actually added support for transformers.js. And the guy who was originally doing open source contributions on this project actually was hired on by Hugging Face, which is really interesting. So they're adding first class support for it on the APIs. And if you want to do custom usage, you can do that if the model is not supported right off the bat. But they have pipelines, and we'll look at the pipeline API in a second here. This is for transformers. It abstracts away the tokenizer in the model. All you need to do is load in a pipeline, tell the pipeline what you want to do and the model you want to use, classify a segment. And so this is sentiment analysis. This will give you, it's essentially classification, but for positive or negative, like a sentiment on your input, and it will give you the score and the output label. And that's how simple it is to use these models now. It's pretty crazy that all that's abstracted away for us. So let's take a look here. There's also one more before I hop into my my demonstration. If you want to do just supervised learning, the models are generally much smaller, much faster. They're much, if you want to load them in on the client, like size can be an issue for sure. Some of these models are up to 1 gigabyte, which is not realistic to send to the client on every page load. But something like a random forest, it's a decision tree, or it's a bunch of decision trees that vote on different inputs, and it does classification as well. It's not, you can't do zero shot with it, but you can do, you can train it yourself. And this is all done. I haven't messed with it yet, but they give you options to train on your data and load the model in all in the browser, which is really nice. So let me show you how an example of one of these models running in the web. I'll pull up here. So this is a Chrome extension. Extensions are a great option for running models in the web because you can load them on the initial download of the actual extension, and then they can just be stored in your browser to be used whenever you want to. So for this one, I'm constantly making Chrome extensions that help my productivity. And this one is one that takes all of the YouTube titles on the initial page load, and it runs them through the model to test if they're, you know, entertainment or if they're actually educational, and it will hide all the ones that are entertainment. But to load the model in, we have to do some fancy stuff with caching, as well as we're selecting an Onyx runtime, which is like a standard runtime for machine learning models that can be run on the web. But we're selecting the WASM backend, the WebAssembly backend, and we're setting the number of threads to 1, unfortunately, so the model runs much slower. Generally, we do web GPU, which is like the new API, but it's not available on service workers yet. So we just have our class here that we're implementing to store it for later after we instantiate it. We're selecting zero-shot classification for our pipeline. This is the model that I was showing earlier that we're pulling, and I've loaded in locally on my extension. You just pass in the task in the model and then a progress callback to tell you what's going on. And then, yeah, I just have it running on initial load. And then whenever the request comes through to, when you hit YouTube, and it gives you a big array of titles and things like that. So let me demo that real quick, and we can look at the console of the service worker. Okay. So right now it's updating it's loading in the model on initial load, and it'll give us this progress callback as the model is being loaded into the browser. The model is roughly 300 megabytes that we're using, which is pretty large for something that I would generally use, but it does pretty well. So now we can see it's been loaded in, and it's given us the classifications based on this dummy data we did for just the test. So the labels are mobile, account, access, website, or billing. And the string we passed it was, last week I upgraded my iOS version, and ever since my phone has been overheating whenever something. But it's pretty clearly mobile, and that's what the network has selected. The highest value here is 0.89, which is mapping to mobile. So now if we went over to YouTube here, I have no idea. This is my work account, so I don't know what's going to be coming up. Oh, good. But we've got our classifier loaded in now. The model's already loaded in. It's got a bunch of different promises that have been loaded in. And then each of those is going to be handled by the model separately. And did my tab not work? Got a bug. Let me try this one more time. There we go. All right. So did anything get removed? Yes, one thing did. Coffee, relaxing jazz. So far, it's been the only thing to be removed from the just the title's been removed as a proof of concept. But yeah, it just performed inference on all these titles. Oh, this one got removed as well. So that's all happening in browser. There's no external calls to any APIs, no models being loaded in. Everything is happening directly on the client. Your data is safe. And yeah, nothing is being sent out. Does anyone have any questions? Do you want to go over the pipeline API more? I have a couple more demonstrations I can talk about, but other than that, that's pretty much it.